I want to show you something very interesting with ZOT and structured outputs, something that feels productive in TypeScript when you're writing it, but can actually hurt LLM's performance and will cost you 2 times more tokens. There are many cases where you want to have different data based on the type. And if you look at this schema right here, you will notice that we have defined this discriminated union, and our discriminator is a type. And what it allows us to do, if we look at one of the schemas, for example, single question schema, you'll notice that we have defined type as literal, single, and we can define custom data for this specific type. You will notice that for text question schema, we don't have options, which makes sense. We don't want to have options for text question, for example. And if I parse the schema, so let's define the data, validate it. And if we look inside of the if statement here, we can be sure that all the data that is going to be inside of this validated data is going to be specific for this single selected single question schema. So here, for example, we're going to have options, and it's all type safe. And if we check for text selection, text question, what you will notice is that we don't have option, which is expected. In our schema, we don't have any options. But with structured outputs and LLMs, it's a little bit more trickier than that. What we're doing under the hood is that we are transforming this ZOT schema into JSON schema. This way, LLM can understand what type of data we want in which structure. And if we look at what we're sending to LLM with discriminated union, we can check it by doing ZOT.toJSON schema and pass our schema. You will notice that we have here items and any of. And each of the item is defined as an object with the parameter of type, text. So this is our text question. Here we have our single question, and you will notice that we are including options here with single question, and for multiple questions it's going to be similar. So the problem with this approach is that first, as you can see, it costs a lot of tokens. So you can imagine that with each request, all this schema is going to be passed to LLM, and it's quite a lot. Second is that LLM doesn't really understand it really well, this any of. What I notice is that LLM fails much more often with this discriminated union types than with just simple example that I'm going to show you. And also, if you think about it, in training data, I don't think they have many of the instances to train LLM on with like discriminated unions and stuff like this. I think in training data, I don't know, but I assume that they would have more of a simpler schemas in training data than complicated any of discriminated union structures like this. And if you look at simpler example of that, you will notice that we have only one object where we're defining all the options and all the possible fields that could be in the schema. But inside of the describe function, so this field describes to LLM what this field is for. And inside of this function, we can specifically tell it to, first we need to specify that it's optional. And we need to describe it that, for example, options are only available for single and multiple choice questions and not text questions. And after that, if we need to, we can also refine. So what refine does is that during runtime, we can check for types and be sure that, for example, with text questions, we don't have any options. And for single and multiple selection questions, we always have like more than one option. And if you want to have all the good stuff, all the good developer experience that you got from discriminated union, you can still have this discriminated union type or schema, but not send it to LLM. But instead, what you can do, you can parse it after LLM returns the object. So let's say we have our data, which is going to be just an empty object. And let's say this data is what LLM provided us. And we can just parse it through our discriminated union schema, and then we will be sure that our data matches this discriminated union schema. And if we look at the schema that we're sending to LLM with simpler schema, you will notice here that first it's going to cost us much less tokens, and I'm going to show you the difference between discriminated union and just simpler schema. But you will notice here that we have items, and now they're objects. So items is type object, and we're describing the properties. And here we have all our properties with the description that we've provided to describe function. And if we look at token consumption, you will notice on the left I have schema with discriminated union, and on the right I have a simpler schema. You will notice that discriminated unions consume 2 times more tokens, but also the more tokens you will input into the LLM, the dumber it gets, especially with this kind of complicated schemas. You will definitely get more intelligence out of simpler schemas than with just complicated schemas like this. And so by switching from discriminated unions to just plain Z object, you can save 2 times more money and you will get more intelligence. I think it's win-win. And for DX, as I said, you can parse into discriminated union after LLM outputs the response. I hope you found this helpful. If you have any other suggestions that I should cover, let me know in the comments, and I'll see you in the next one.